So now we start chapter 22, which is electric fields. So first thing is, what is an electric charge? And we know that there are two kinds of charges, a positive charge and a negative charge. So if we look at an atom, we have the nucleus, which contains protons and electrons, and then there are electrons going around it, first shell, second shell, third shell, and so on. So we have electrons, which are negative, and we have protons, which are positive, and neutrons, which are neutral. So the charge on the proton is exactly equal to the charge on the electron, but in the opposite direction. Now, in an atom as a whole, the number of protons and the number of electrons are equal, and therefore the atom as a whole is electrically neutral. Now, if you take a material, an object, and it has a large number of atoms in it, and somehow if we add a few electrons into it, then this whole thing will now become negatively charged. And the amount of charge will depend on how many electrons we have added onto it. The charge on each electron is written with the symbol E, and that's equal to 1.6 into 10 to the power minus 19 coulombs. So that's the electronic charge. For an electron, this would be negative. For a proton, it would be exactly this magnitude, and it would be positive. So if we are pushing in electrons in here, suppose we add 3 electrons into it, then the charge here would be 3 times 10 to the power minus 19 with a negative sign. So the Q is going to be N times E, which would be, if we had 3 electrons, 3 into 1.6 into 10 to the power minus 19 coulomb with a negative charge. So that's minus 4.8 into 10 to the power minus 19 coulombs. Now, coulomb, this thing is a coulomb, and that is the SI unit of charge, which we will see later on what it really means. But let's assume for now that it's a unit of charge. Similarly, if we were to extract some electrons from it, then the whole thing remaining would have a net positive charge. So that's how we can give positive and negative charges to different objects. Now, if we have, let's say, a glass rod, and we rub it on silk, so what happens is that the glass has less electronegativity or less affinity for electrons as compared to silk, and so silk will manage to take some electrons from the glass. So when you rub it on silk, some electrons will go from the glass to the silk, and the result is that the glass rod will become positive and the silk will become negative. And similarly, if we take a rubber rod and rub it on fur, then the fur will gain a positive charge and the rubber rod will become negative, because the rubber rod will pull the electrons from the fur. And then we know that if we bring a glass rod like that and one of this rubber rod, which has been negatively charged, then the two will attract each other, and there will be a force of attraction between the two. So if we have these two charges that are opposite, so we see that opposite charges or unlike charges attract each other. And if we have like charges or similar charges, then they repel each other. So if you have a positive charge and a positive charge, then the two would push each other away, If you have a positive and a negative, they will pull each other together. Now, if you have an object that has, for example, a negative charge, and we want to use this object to charge something else, so we can do that either by conduction, which means that if this is neutral and we bring this together and we touch it, so when it touches it, some of the negative charge from here will go on to here, and if this had, let's say, 6 charges, it could have 3 left, and it would have 3 left. So, and then you can separate them, bring them apart, and well, this has 3 charges, this has 3 charges. So this is charging by conduction. Another way of charging is charging by induction. And in induction, we would bring this charge close to this one, so it comes close. And what it does, if this is metallic, that because of the negative charge, it pushes the electrons away, and the electrons sort of collect on the other side. And then if you touch it with your finger, or with what we call an earth, if you touch it with the earth, these electrons will flow out into the earth, and then you move this away, and this charge, this still has the 6 charges on it, and let's say 3 of these went into the earth, so now this would be net positive charge because it has a shortage of 3 negative charges which have gone away. So you can charge something positive by using a negatively charged object, and you can repeatedly use this to charge other objects. So this is charging by induction. You bring it close, do not touch it, and then move it away. But before you do that, you touch it with an earth to take out the charges. And this works when this is a conductor, because in a conductor the charges will move away.